This is Foundations of Math and Pre-Calculus 10, Chapter 8.3. We're going to look at the number of solutions for a system of linear equations. Here, we have one solution. Here, we have an infinite number of solutions. We call this one intersecting lines. This one we call parallel and coinciding lines. Here we have parallel lines, but they're not coinciding. So we have 0 solutions. Box our answer. We'll circle the intersecting points. We'll circle the intersecting point, and there's one solution here. Again, this is intersecting lines. Here we have intersecting lines. At different pairs. But all 3 lines are not going through the same point of intersection. So we have no solutions here. So the possibilities are no solutions, one solution, or an infinite number of solutions. There are no other possibilities. And just a reminder, this is infinity, or in our case, it's infinite. So by looking at the graphs, it's fairly easy to tell. And here's an enrichment topic. We can classify systems of equations using the number of variables versus the number of equations. If the number of variables is greater than the number of equations, it is called underdetermined. If the number of variables is the same as the number of equations, it is called exactly determined. And in our unit, we have mostly this type of question. If the number of variables is less than the number of equations, it's called overdetermined. So since we are dealing with 2 variable equations, all we need is 3 or more equations, and it's overdetermined, as is the case here and here. So for the number of solutions, if we have no solutions, the system is called inconsistent. If the solution exists, then the system is called consistent. And dimensions. So if we have a single variable equation, it represents a point. If we have a 2 variable equation, it represents a line. And for the tricky one, if we have a 3 variable equation, it represents a plane. And this is not an airplane. This is a 3-dimensional flat plane. So to determine the number of solutions algebraically, we need to put all the equations in the same form. If they have different slopes, then there's one solution. Because if the slopes are different, they have to cross somewhere. If they have the same slope and the same intercepts, we have an infinite number of solutions. If we have the same slope and different intercepts, then we have 0 solutions. So let's try a few questions here. How many solutions? Well, we need to do algebra on this one. So 5x plus 6 equals 3y. 3y, negative 3y from this side moves over to the other side, becomes positive, and then we divide everything by 3, and we get y equals 5 over 3 plus 2. This is identical to this, and I'm missing an x. So there's infinite number of solutions. Okay, we're not looking for the solutions, we're just looking for the number of solutions. So please don't do extra work if it's not asking for it. So what can we do here? Well, we have one slope, so we can convert this over, get another slope. So 3y, bring everything over, and they become negative. So we can immediately say there's one solution. And the reason is, this is positive, this is negative. They can't possibly have the same slope, so they must be intersecting. If you did want to finish this off, we have negative 4/3 x minus 7 over 3. Okay, next, we can move everything to this side and avoid dividing. So 2x plus y minus 5 equals 0. These have the same slopes, but different intercepts. So this is 0 solutions. These are parallel lines. Next, we can solve for y here. Move everything over to the other side. We get 10y equals negative 5x minus 3. Simplify. We have y equals negative 5 over 10. That's negative 1/2. Negative 3 over 10. There's not much we can do about that. Okay, we have the same slope. We have different intercepts. So again, 0 solutions. And let's look at a couple more problems. We can convert this. This time we'll just move the 4y over to the other side. We'll leave the 12x and the 16 on this side. Divide everything by 4. And we get y equals. It's okay to flip sides for both of them, and then you don't end up changing any of the signs. So 12 divided by 4, that's 3x. 16 divided by 4 is plus 4. And we have an infinite number of solutions because the slope and the intercepts match. Let's look at some problems in the textbook. Okay, here's the following statement. True or false? Explain and provide an example to support your answer. If a system of linear equations has an infinite number of solutions, so we have infinite number of solutions, then any pair of numbers is a solution. Okay, let's use a simple equation. Suppose this is our answer. That means we have a graph like this, graph like that, and an equation like that. It says any pair of numbers is a solution to the system. Well, that's not a solution. The solutions are very specific. It has to be on this line. And we can see that Since y equals x, we have x comma x. All these points are solutions. Let's look at number 12. Suppose you are given only the following pieces of information about a system of linear equations. Would you be able to predict the number of solutions in the system? Okay, the slopes of the lines are the same. No, you cannot predict. But it's going to be 0 or infinity, because we don't know what the intercepts are. If they're the same, we have an infinite number of solutions. If they're different, we have no solution. We have no solutions because the lines are parallel. Okay, here it says the y-intercepts of the line are the same. Again, no, we cannot be definitive. We can have one or an infinite number of solutions, depending on the slopes. We're not told what the slopes are, so we can't say anything about it. If the slopes are different, we have one solution. If the slopes are the same, then we have an infinite number of solutions. 13 says the x-intercepts are the same and the y-intercepts are the same. That means we can only graph it one way. Same, same, must mean they're on top of each other. So yes, and there are an infinite number of solutions. Again, we don't have to say what the solutions are, so don't waste time calculating it if it's not asking for it. Okay, let's look at the last one, number 19. Can a system of two linear equations have exactly two solutions? Well, the answer is no. The only way to get two solutions is to bend your line, is to add a curve. So we have a solution here and we have a solution here. So if it's straight, it's only ever going to cross at one spot. So it's only going to cross at one spot when we cross at no spots, or if it's on top of the other one, then it crosses at an infinite number of spots. So again, we can't get two because it's not a line. So here we'll just say only 0, 1, or an infinite number of solutions. And that completes this lesson.